Hello everyone, welcome back to my channel where I teach you everything you need to know about data structures and algorithms in JavaScript. In this video, let's implement our pop function. A pop function can be used to remove the last node from a linked list and return it. But how do we remove the last node from the linked list? We will have to do two things. First, we will have to break the link between second last node, that is C, and last node, that is D. To do this, we will set c.next property to null. But how do we access C? We don't have a direct reference to it. We only have access to the head and the tail pointer. Second, we have to update the tail pointer to point to the new last node, that is C. But again, how do we access C? We don't have a previous property that points to the previous node in the list. So it seems like we need access to C and D in order to remove D from the list. How do we get access to them? Well, one way to do this is by using two pointers, A and B. You can think of A as ahead and B as behind. They will both start at the head of the list. Then we will use a while loop that will run as long as A has a next node. Inside the loop, we will have two things. We will set B is equals to A. This will move B one step forward in the list, and we will set A is equals to A dot next. This will move A one step forward as well. Let's see how this works in our example. Initially, both A and B point to the head of the list, which is A. Then we will check if A has a next node. It does. So we will enter the loop. We will set B is equals to A. Nothing changes here. We will set A is equals to A dot next. Now A points to B. We will check if A has a next node. It does. So we will enter the loop again. We will set B is equals to A. Now B points to B as well. We will set A is equals to A's next node. Now A points to C. We will check if A has a next node. It does. So we will enter the loop again. We set B is equals to A. Now B points to C as well. We set A is equals to A dot next. Now A points to D. We check if A has a next node. It doesn't have a next node. So we exit the loop. Now look at what happened. We have access to both C and D through the pointers B and A respectively. Now this is what we want to do. We can set this dot tail is equals to B. This will update the tail pointer to point to C. We can set this dot tail dot next is equals to null. This will break the link between C and D. We can decrement this dot length by 1. This will reduce the length of the list by 1. And finally, we can return A. This will return D, which is the last node that we removed from the list. And that's how we implement pop function for a linked list. But wait, there are some edge cases that we need to consider. What if someone tries to pop on an empty linked list? In this case, there is no node to return. One simple solution is to check its length, and if it's 0 before doing anything else, we will return undefined and exit the function. This will prevent any errors of unwanted behavior when popping from an empty list. Another edge case is when there is only one node in the list. In that case, our while loop will not run at all because A's next node will be null. So we will have to end up with both A and B pointing to the same node, which is the head and the tail of the list. Now, if we follow the same step as before, we will end up like this. We will set this dot tail is equals to B. This will not change anything because B is already the tail. We will set this dot tail dot next is equals to null. This will not change anything again because B's next node is already null. We decrement this dot length by 1. This will reduce the length of the list to 0 and return A, which is the only node in the list. Now we have a problem here. Notice how the head and the tail still point to the node and we have not yet removed it. That's not what we want. We want our list to be empty after popping the last node. So how can we fix this? Well, one simple solution is to check if this dot length is equals to 0 after decrementing it by 1. Then we will set both this dot head and this dot tail point to null. This will make our list empty as expected. And that is it. We have covered all the edge cases and implemented a pop function for a linked list. Now let's see if our code works or not. Here we have a linked list with one node, A. We push B, C and D into it using pop function, which we learned in our previous video. Now we will use linked_list.pop to remove the last node from the list. This returns D, which was the last node of the list. And now let's see our linked list. It has a new tail. Its new tail is C and its length is 3. Now let's use pop 3 times more to remove all the nodes from the list. And as you can see, our linked list is empty now. So that was pop function in a linked list. Now let's talk about its time complexity or big O notation. We have to iterate over the entire list using a while loop. So this was an O of n operation, where n is the length of the list. That's quite slow as compared to arrays, where removing the last node was O of 1 operation. So if you want to use a data structure where you constantly need to delete from the end of the list, linked lists are not for you, and you should rather prefer arrays. But in the next video, we will talk about a method where linked lists shine while arrays are slow as heck.